Hi, everyone. So for the second half of topic 7, we're going to be talking about 3D figures, and this is going to be lesson 7-5. I'm going to call it part 1, because we're not going to draw nets of 3D figures yet. We'll do that in part 2, but we need to know how to identify 3D figures. So in front of us, we have a box. But that box is a 3D figure. We're going to be looking at 3D figures called polyhedrons. And what a polyhedron is just a 3D figure that is made up of different polygons. So this box has rectangles on the sides, things like that. So we're going to talk about different parts of those 3D figures for this lesson. So the first thing we're going to do is start with something called, actually, let's figure out some parts first. Let's look at example 1. So if you want to look in your book, this is page 414, already a little larger right there, if you want to look along in your book. And it says, a polyhedron is a three-dimensional solid figure made of flat polygon-shaped surfaces called faces. So the flat parts that go across, they are the faces. So if I go back to the box, this has a face on the right there. Let me highlight it pink. There's a face right there. Okay, it's a side of a box. That's one face. It has a face right there to the front. And it has a top face right there. Do you think those are the only faces that box has, or does it have more sides to it? That box actually has more sides to it. We just can't see them right now. So if this box has a top in that blue up there, it's going to have a bottom down below. So sometimes I'll do my best to draw. I'm going to make this so we can kind of see through this box. Okay, and now if we think of it as clear, we know that box is going to have a top, a bottom, a right side, a left side, a front, and a back. In all, this box would have 6 faces. Okay, so again, a face is entire flat side. If you want to grab a normal looking box to see that has 6 faces when it's closed, you absolutely can in your house. So that would be an example of a face right there, would be that green area. So when we look at 3D figures, we can look at the number of faces they have. So that would be faces right there, and it's pointing to the flat surface going right there. That is a face. Okay. Now, some of those faces are called bases. And here it says the top and bottom of a prism are called its bases. So, prisms, this is an example of a prism. Prisms have 2 bases, a top and a bottom. Okay. This prism is called a rectangular prism. And we'll go more into that in a little bit. It's called a rectangular prism because its bases are all rectangles. So 6 faces, and 2 of those faces are bases. Some other things we could look at when looking at 3D figures, we could look at something called an edge. Okay, so if I look at an edge, it is those side corners right there where I'm highlighting. That's an edge. That's an edge. That's an edge. There's another edge. So I want to look at this box right here and figure out how many edges. So far I had 1, 2, 3, 4 edges. I see 5, 6, 7. But now there's some I can't see, and that's why the dotted lines are there. Those are what I can't see when I'm looking at a box. So 7, 8, 9, 10, 11, 12 edges in all. So if I go back to this box, it's going to have 12 edges. And again, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 edges. The way I remember edges is that when I was a toddler, I hit my head against an edge of a dresser somehow and had to get stitches. So edges. And the last part we can look at, if I go back to example 1, is something called vertex. A vertex are where the edges come together to form a point. So I see there's a point right there. There's a vertex. There's a second vertex, a third vertex, a fourth one, a fifth one, a sixth one, and the two I can't see, a seventh one, and eighth one. So this has 8 vertices. Vertexes. We can go with the vertexes for now. Okay, so 8 vertex. So that's our polyhedron. We're going to be looking at faces, edges, and vertexes. And again, look at page 414 in your book, and it points to those examples. Okay? Vertex is the point, an edge are the sides right there, and a face is the whole entire flat part. All right? So let's look at prisms, because I said that box is a prism. These are examples of prisms. This is also on page 414. Sorry, it's writing with the highlighter. Prisms always have 2 bases, a top and a bottom. So if I look at this rectangular prism, it is called a prism because it has 2 bases. It has a top right there, and I'll do the bottom pink, and a bottom. And prisms are named after their bases. Because these bases are rectangles, we're going to call it a rectangular prism. Now, for this next one, this is a triangular prism, because if I look at the top base, right there, it's a triangle. And the bottom of it is also a triangle. So its bases are triangles, so therefore it is a triangular prism. And even if I turn that sideways, though, if I flip it, and I did that right there, even though the top and bottom are kind of sideways now, I'm still looking for those 2 bases, even though everything else is a rectangle. They're right there, and that's still a triangular prism. So we name polyhedrons based on their bases, okay? So this part down here, they have 2 identical parallel polygon-shaped bases. All right, the bases are tops and the bottoms. And then prisms are named by the shape of their bases. So if I think of this one over to the right, that one right there, I need to think of the shape of this base. See, 1, 2, 3, 4, 5, 5 sides right there to the top face. That would be a pentagon. So I would actually call this a pentagonal prism. Oops. It has a top, right there. That's a pentagon. And it has a bottom. That's a pentagon. And even if you turn it sideways, it still counts as a pentagonal prism. Over here, even though the top and bottom aren't really on the top and bottom, they have those 2 unique sides. I see one here, and that looks like a hexagon to me because of its 6 sides. And I see one in the back. So this one would be called a hexagonal prism. Today we're going to be talking about prisms and something else called pyramids. Okay? Prisms, 2 bases. Pyramids, though, are a little bit different. Pyramids only have 1 base. And on the opposite side of that base, there's a vertex where the triangle faces meet. So at the very bottom, here's a base. But on the other opposite end of it, there is a vertex forming a point. Again, over here, there is a base. I'll switch colors. And at the very top, a vertex. So only one base for pyramids. Pyramids is up there. Again, this is page 414. One base, but we still name the polyhedrons based on their base. This one's called a square pyramid because the base, the bottom of it, is a square. This one's called a triangular pyramid because the bottom of it, right there, is a triangle. Okay? Here's an example of one of the Egyptian pyramids. This would be a square pyramid. And again, there's one base, a bottom, and on the other end of it, there is a vertex at the very top. So that's the difference between pyramids and bases. Okay? So to recap, you need to know the difference between prisms and bases. And again, prisms have two bases right up there at the top, two bases. Pyramids have one base, and we also need to know the different parts. For these polyhedrons, these three-dimensional objects, we're going to have faces, which are the flat parts. There's a face, there's that flat part. A vertex, which is where all the edges form together, and the edge, which is those sides, just like that are the edges. Okay? Face, flat parts, vertex, point, edge, the sides. Okay? And again, if I look here, there's a normal box. There's 6 faces, 12 edges, and 8 vertexes. You can go find a box in your house and go play around with that. So do the practice for today. Join a Zoom session if you need help, and then there will be an exit ticket. There will be an exit ticket for tomorrow. And then in 2 days or in 3 days, we'll finish this lesson of 7-5. This is only part 1 of 7-5.